Hi guys, I hope you're good. Here we're going to lecture number 4. This is the beginning of chapter number 2. So we'll be speaking about the application layer, and the application layer has a lot of nice and cool things in there. It's like we will see a lot of things that we'll start applying coding onto. All right. So as I said, we're going to chapter number 2. Let's speak about the very first items we need to know about this. So our goal is to make sure that we have an understanding of basically whatever constitutes the application layer, what is a client, server, paradigm, what is a peer-to-peer one. So we need to understand also what a circuit is like, and I'm sure most of you heard about APIs before, and how to secure our communication when we speak from one computer or one network entity to the other one. Okay, so the multiple network application that we know today is like multiple categories. It's like most of them are social network. We have our Twitter, we have our Facebook, all of those stuff, and you have Skype. Like you see, you have a lot of these applications today that will help you to communicate, and there are multiple of them. It's like you can actually choose your favorite, whatever. But how does it work? How does all of those elements work, right? So you at the beginning you have your whole environment here, right? Remember, you have your networking devices, you have your switches here or routers, and then you have your servers, right? Most of the time, when we have these systems, for them to communicate, right, or for us to have a network, we need to have these little entities, which are network components, right? Each of them basically they do have all the internet, all the different internet layers. Remember all the layers, right? Starting from the application to the physical, and this is an internet, right? Or a TCP IP stack. Each of the computer of the network, they do have these layers. And after that, they communicate. They just communicate through the applications, right? Through the application layer, and then the underlying layers just deal with the rest, right? So this is basically how it works. And what like in programming, you can write your program in any language you want for your different systems to discuss. So in our case, we'll be using Python. You can use Java, you can use whatever language you want, but I'll be giving you assignments and labs using Python. So you will be writing code for the end devices, like for a phone, for a laptop, or for a server running somewhere. But then we will not be running code for the after the application layer or for the network devices. There's no need for us to write that. So we assume that they work already. So the client server paradigm here, um, it's a very powerful concept. It's a very powerful concept that you need to know. So you have to know a client. You have to see a client as an application that requests something, right? It's an application that wants something to be done. And then a server, it's an application that receives a request from a client or from different clients. So you have to see that a server is always on. Right? A server needs to be always on. It needs to have a permanent IP address that we can call. Like if you want to speak to Facebook, then we know that Facebook is facebook.com. Then we have that. There's a lot of mechanism at the back to basically to be resilient to failure and all those stuff for the website www.facebook.com to be always working. But then take it as facebook.com for now. Say that that IP is static or permanent, and then that's the only one we'll call. And most of the time, the server doesn't always reside in a single computer. It can be multiple different computers and then end up being a data center. Now a client, it's like this is a server and the client speaks to a server. Now we have the clients here. It's like the clients are basically applications, right, that do requests to the server. Right? They communicate with the server. They may speak to each other. It's like in this case we'll be speaking about a peer-to-peer connection. And yeah, I mean, it depends. They do not directly communicate to each other. Okay, they do not directly communicate to each other in a client server already. Yes, but then in the next set of slides, they can or they may communicate to each other. In this instance, we have the HTTP, which is your normal browsing entity. So obviously, for us to browse, we need to speak to a server. The IMAP and then the FTP. It's like there will be always a server so that we can request something from the server and get something from the server, right? So this is our client-server architecture. Now our peer-to-peer architecture, right? You may have at least one server. You may not have a server. Yes, you may not have a server. So you see the phone can communicate directly to a computer in the network without actually passing through a server, right? So your client server application, as we saw, it was a simple HTTP connections, like you making a request to Google. This means that you're going to Google's server and then you're getting your information to have your social network, right? And in this instance, we speaking to another computer, yeah, to have information about that, right? It's like peer request service from another peer provides service in return to other peers. Like since a peer-to-peer network is just made of peers, right? One computer and another one. It's very, very scalable. It's like you just need to have a bigger group or a bigger network of those computers, so it will become more resilient as opposed to the client server architecture, where you need to make sure that we grow the number of servers, right? That's basically what we have. But then there are some things that we need to speak about. It's not directly related to this class, but since we're speaking here about scalability, there there are some stuff that you need to know. But before we get there, some application of peer-to-peer application is what you know very well. It's BitTorrent, right? You have BitTorrent for peer-to-peer file transfers or downloading, and you have Skype, right? Skype, your internet protocol telephony application that also uses peer-to-peer. It's just like that, it works as well. But then in terms of scalability in networking, you have two sorts of scalability. You have the vertical scalability, which basically says that you have a computer, right? You have a computer that has 32. Sorry for my handwriting. You have a computer that has 32 gigs of RAM, right? Yeah, you have, this is vertical scalability, a computer that has 32 gigs of RAM. So when you want to scale it vertically, you mean that, okay, we adding more RAM to this computer, maybe to have 64 gigs of RAM, Yeah, right. But then this is in a single computer. This is this one. We're just boosting the numbers of resources. If it has CPU, one CPU, then we increase it to maybe two CPUs or three in the same box, in the same computer, in the same server host, right? But then we have the vertical scaling, and then we have the horizontal scaling, right? Vertical scaling is basically when you have a single computer and then you say, okay, cool, you know what, and let's just put much more resource into it. It's like we just buy more stuff for this computer. But then the horizontal scaling is usually what happens today. So you have a little box or you have a little computer that has 1 gig of RAM, right? And what you do is like, okay, we have much more loads coming into the picture. Let's add, for example, five of these 1 gigs, and hopefully the load will be well spread, and then the workload will be smaller because it's been distributed across all these little other computers. So you have to know your your vertical your vertical scaling, right? And then you have your horizontal scaling. Those are two important stuff that you need to know. Very, very important in networking. All right. So we have the communicating processes. So a process in networking or in computing in general is a running program. So if you opened your task manager, right, you would see that you have multiple processes running, right? In my case, I have multiple processes running in this computer, right? These are the processes and these are the different apps that I'm running here, right? If a process is running within the computer, like we're talking about inter-process communications, like maybe Internet Explorer, uh, maybe Internet Explorer is speaking to Microsoft Word, and the Microsoft Word is speaking to another thing. It's like yeah, it's basically working that way, right? So when processes are in different environments, this is a very interesting one. Let's assume that you are driving a car, right? You are driving those Tesla cars, for instance, Tesla. But then now, maybe the wheels are trying to tell the computers that one wheel is being deflated. This is like, okay, the rails will then try to communicate with the computers by sending some messages. It will send a message to the computer, and the computer will receive the message, unpack the message. The rails, basically the rails are being deflated, and then the computer will take action. That's basically how it works. So this is for the processes and the communication between processes either in the same system or in different systems. So in the same system, we're talking about inter-process communications, so like they communicate directly, and then within different systems, different environments, then we're speaking about message exchanging. It's like the message are being passed around. But in the sense of the client server, right? When we have a client, right, the client is the process, it's a process in a host or in a computer that sends a request, right? A client, it's somewhere sending a request. It sends a request. The client always sends the request. And then the server basically here receives the request and takes action, can respond directly to the client. And take this example again as Facebook. Facebook doesn't know anyone in the world, right? So like doesn't know any computers in the world until you make a request to Facebook server, and then Facebook server will acknowledge you that okay, you have an account with us, then you might have some information that we can give you, and then they give you an information. So you are a client, you have an application, you have an account with Facebook, and then they send you back your feeds. So Facebook now is what we call a server process. They listen to everyone, they listen to like everyone's requests to make sure that first of all you're being authenticated, and then you're authorized to take a very specific amount of information about yourself, and then it will send you the request. Cool. So peer-to-peer applications as well, they have also some sort of client-server processes depending on what does what. Remember that a peer one is equals to peer two in terms of their structure. Those are computers, right? But then if there's a file here, right, and then peer two wants this file, then this computer becomes a server and this one becomes a client. And the other way around also works, right? If peer 2 has a file and peer 1 wants that file, then this one now becomes the server, the client, because he wants that file, and this guy becomes the server. So other way around. But the only thing you need to know, a server is a listening application that waits for requests from the client. A client is an application that is making a connection with a server or a communication with a server. All right. So this is also a very important one. A socket. A socket is literally, as the slide first is saying, is a process that sends or receives messages. Right. A process that sends or receive messages, or a socket. If you know exactly, if you remember exactly the internet stack or the TCP/IP stack, a socket is an interface between the application layer and the transport layer. This is what you need to know. So an example or an analogy of the socket is just a door, right, or something, or like a postman or something. You're sending a message out the door, and then you're relying on the whole transport for the message to happen, right? So the socket is that thing that takes your message and has the information about the destination, right? We'll be writing code about that, and then you'll be definitely understand what it is. So you see, you have in this case, right, the application right here and the process tied to this application. They all come and give all of that to the socket, and then it brings the message down there straight up to the receiving end, whereas the socket has a lot of important informations about the message, the destination, and a lot of things that just happened. All right, so addressing processes, it's like to do anything we want, right, on the internet, we need what we call basically an IP address, right? We need to have an IP, internet protocol. This is a protocol, internet protocol address. Currently, we're using what we call IP, and then they are 32 bits, and we'll be doing all of that process later of why there are 32 bits and how basically how they defined, right, in the network. But then they are 32 bits IP addresses, and that's what we call an IPv4, the fourth version of the IP, as opposed to the other version, IPv6, right? But we're basically moving towards IPv6 before, because we do not have any IPv4 spaces anymore. The world is growing too fast. IPv6 will have much more space into storing those new IP addresses, right? And then the question, does IP address of a host on does IP address of host on which process run surface identifies identifying the process? Does an IP address of a host, right, on which process runs suffices to identify the process? No, it does not, because in a single computer we can have multiple IP addresses, starting by your local or your home IP address that we all need to remember: 127.0.0.1. This is your local address, and then you have your network address, and then you have your other addresses. All right. So let's just get rid of all of this. All right. So, like I said, an IP address basically is an identifier that basically tells you what's the name of this computer on the network. And if you want to connect to a particular application, right, or if you want to deal with a particular application, then you need to have a port number. And these ports are very, very, very important, because if you want to connect to Facebook, for example, using the browser, you definitely will be using some like HTTP or HTTPS. HTTP is off port 80 and HTTPS is 443. This is the secured one, this is the non-secured one, but it doesn't matter really. You just have to know that HTTP has the port 80 and HTTPS has the port 443, right? SMTP, which is the mail server, has port 25, and you need to know about that, right? All right. So we basically have the application layer protocol. The application layer protocol define some things that you need to be aware of, right? We need to know about the type of message exchange, whether it's a request, it's a response used in the transaction, like a request from the client, a response from the server. We need to know what is happening, and then in normal communication, it's either a get or a post. So you're posting a message, you're getting a message, you put. There are multiple of these type of messages that we will be dealing with when we'll be doing our little web page or our little application programming interface, or as known as API, right? The message syntax. What field in the message? What field in messages and how fields are delineated? Delineated. Yeah. So basically, when you send a message, right, and in fact, those two. When you send a message to the server or to the client, there is a way that the message is being packaged so that the clients understand exactly what's going on. Like it can be in a what we call a JSON file, it can be in an XML file, it can be in a particular format that you can define so that the server understands the response of that particular message. And then there are rules about how the message should be treated, should be responded, should be processed, right? And other than that, there are multiple other elements that are there in the application layer protocol so that the message is treated as it should be. It's like, for example, when we have a message coming with HTTP, then we have to know that it's coming with a port 80 and it's just for browsing. And then SMTP, we're speaking about a mail service. All right. So what the transport layer does, what transport layer service does an application need? An application needs basically these four services, which are the data integrity, the timing, the throughput, and the security. And we heard about some of these entities One of them is the throughput, and we'll start by that. Basically, some applications require more bandwidth and some applications might not require bandwidth. So those applications that does not actually require that much bandwidth are called elastic. Elastic apps are the apps that will do with any bandwidth that's available to them. It's like messaging applications, whether you have 10 megabits or 1 kilobyte or one whatever size, the messages will go slowly, but then they will go. It's not really required. But then, if you basically want a bandwidth effective application, then it will be very important for you to have a high throughput in your links, right? We're speaking about maybe video calls or I don't know, or video games, stuff like that, where you would want to have the highest uh, like throughput in between the links or in between the hosts so that your experience is better, right? So we need that to basically do what we want. Security comes with data encryption and basically the integrity, and in most common websites, if you open maybe Yahoo or Gmail, you will see a little padlock there. That just means that your connection is secured, and it's basically secured to what we call TLS, right? Or transport layer security, or the former version of it is SSL, which is a secure socket layer, right? So that particular protocol, that particular security layer, just make sure that the communication between the server and the client is secure all the way. Right, a bit of that in the next slides. Data integrity, then you have your nice TCP that makes sure that your data is fully there when it lives from the server to the client. And you have your timing. You wouldn't want to have delays between your data transfers, right? Let's say you're sending a file or you're making a video call. You wouldn't want to have too much delays. Although there are some applications that would allow for delay, again, SMTP or mails, they don't care that much. But then if you're making a video call and then there's a long delay, or if you're sending a file and then there's a long delay, that wouldn't be fine. All right, so here you have just a table of the transport service required by those apps. As you recall, then elastic here means that they do not basically worry too much about the bandwidth, and then when they're not elastic, then they worry about the bandwidth. They would like to have a bandwidth requirement before going through, like file transfer, email, and web document. They basically don't care about the speed of your throughput. It doesn't, the rate of your throughput, it doesn't really matter. But in real-time video and audio, then it's required if you don't want to hear just someone speaking under the water, streaming, and most of these ones, except also text messaging, is basically very elastic. About the data loss, remember UTP can lose some data and all those stuff. But then if you're using UDP and using real-time videos, then we don't care too much about data being lost, because if someone is speaking or if some action is being taken in real time and then you're saying the next one after 1 or 2 seconds, then we don't care of what happened prior to that, right? All right. So Internet Transport Protocol Services, basically this is the TCP, your normal TCP properties that we all know, right? We have a reliable transport. You have to make sure that the transport is fine, and we have to make sure that the transport is fine and arrives well, right? Because it's connection oriented. It doesn't provide timing because there's this handshake property. It just needs to make sure that everything is going well. It's also make sure that the the speed of sending and receiving the message is agreed upon all the parties involved, and it just makes sure that the sender doesn't get overwhelmed because there's that connection between the two, and then they can communicate up front. UDP does not do any of these ones. It's a very unreliable data transfer because of whatever it doesn't do. It's not reliable. It doesn't have a flow control. It doesn't have anything. But then why do we need UDP? Sometimes it could be important. Sometimes we don't need to make sure that the data has arrived well, like in a real time communication in the video, right? So that's one example. Um, the internet protocols using TCP and UDP. A lot of things are using TCP, but using UDPs, what you would see is mostly real-time stuff. Like real-time things are using UDP because we don't care about what happened some few seconds earlier. We just care about what's going on. Now coming to the last slide. Here we have the security part of the TCP, which uses TLS, like I was mentioning, the transport layer security. It's just make sure that the communication between the server and the client is as secure as possible, right? It's uh, it came just after what we call SSL, which is basically the secure circuit layer. It's like you can think about that. So, and you can see that a server it's having a connection through SSL with the lock that is next to the website. And most of you, I'm sure you've already seen that. And it's there to make sure your connection is being secure. Cool. So this is the end of part 1 of lecture number 4. We'll be going through web and HTTP on the next one.